La parola a Paul Jenné, coordinatore del High Velocity Project, obiettivi e prospettive del progetto.
Buongiorno a tutti. I apologize that I do not master your language, so I will have to go in English for the major part of this presentation. Isn't this exciting? Are you not excited? I have the feeling that yesterday and today, you, basically all of us, we are writing history. This has never been done before, that amidst economic and financial crisis, which affect all of us and all our countries, that we have the courage to develop the future, which is, in any event, zero emission. We cannot afford for the future to be polluting our cities and our towns. So I stand here a happy man, because yesterday I found out that this is the perfect setting. You have a beautiful country, you have a beautiful province, a beautiful city. So we have an obligation to preserve it. I am also happy because I found out yesterday that we have a perfect project, which I will explain a little bit later. And I'm also happy because we have a perfect team. You know, we have 5 different countries, member states in the European Union. We have 12 partners, 4 of them being Italian, 4 being Belgian, a Dutch one, a Danish one, and a UK one. So this is a good opportunity to really do something. And when we introduced the project back in July 2010, I had no idea where it would go. Yet we came out to be one of the best, one of the finest projects that has ever been submitted. So we started negotiations to find ourselves in a contract which has rights and obligations. The European Union will be spending money, and we will have to perform. So I think this is a good example of private-public partnership, and we are all committed to make it happen. Let me first walk you through what we do, what we have done in this business, to put your mind at ease as far as the ability for all of us to make it happen. We're a 65 years old company, but no one is talking about retirement. We are looking at the future, which is certainly one that we would have to address anyway. We're 4,000 people, and the output is about 5 to 6 buses every working day. In addition, we are well introduced in North America, which is why Jamie Levin, the next speaker in California, will demonstrate how the product and his system met the objectives. We have, since the UITP in Rome a couple of years ago, we have come to the conclusion that, in one word, we are emotional. The motion being the bus, the E being the efficiency to start with, the environmental friendliness, and since shortly, also electrical. Let there be no mistake. The future of public transport is electric. The bus that you will witness later is, in essence, an electric bus. The only point is, where do you get the electricity from? In this case, hydrogen. We've been doing that for quite some time. As you see, we have CNG buses, which are also very popular in Italy. We have V.LO bus, the trolley buses, be it on the lines or with ultra caps, meaning hybrid. We have diesel hybrids, and of course we have fuel cell buses. And that's the picture that I want to leave you with, especially the youngsters, is what does it mean? How do you translate it? How do you put it in your mind what the effect is, the ecological effect of what we are doing? So I understand you have 150 buses. Take 100 buses out of that fleet, and you will see, for comparison reasons, that those 100 buses will be equal to the uptake of CO2 of 14 hectares of forest. So if all of your buses would be hydrogen, that would be the same as the take-up of a forest of approximately 20 hectares. We would, to make you understand what it is in particulates and in NOx, the harmful gaseous emissions of a bus, that your 100 fuel cells would be equal to 4 lanes of cars over 10 kilometers. So try to picture that. Back in 2005, we started out with a US project. As you can see, it's a golden, but also a Golden Gate experience, in that we have supplied 5 buses to Jamie's company to experience what it is to operate hydrogen buses, and I will let him do the evaluation. We then figured out that an American bus is not a European bus. So we have made the bold decision to build a European bus, because in Europe they have other dimensions, other weight, axle limitations, which of course will affect the capacity and the comfort of the bus. So we decided to build our first hydrogen fuel cell bus for Europe, the very one that you will witness later. We were not alone to do that. We had suppliers like of the fuel cell, as you can see. On the left-hand side is United Technologies. We have Ballard as the supplier of the fuel cell. We have Siemens of the supplier of the electric motors. We have operators to operate the bus, to have the experience, and of course the provider of the hydrogen. In this case, it was Air Liquide, as, and very few people know that, about 3,000 kilometers of pipeline are available in Flanders and in the north of France and Holland, which basically provides the hydrogen as and when needed. We took the bus to the test, of course, for 2 years and 100,000 kilometers, just to find a number of things preliminary. One is everybody loved the bus. The drivers, the mechanics, and of course the passengers. We then considered the fuel consumption, which was around between 8 to 10, depending on the season and also depending on the driver, between 8 and 10 kilos per 100 kilometers. If you convert that into diesel, depending on the cost of your diesel fuel and the cost of your hydrogen, you will see that this is about the same. So already now, with very little volume being available of hydrogen, the cost is equal to a diesel bus of the fuel, well understood. Then Jamie asked us to produce another series of buses for the US, in this case 12 for California and 4 for Connecticut, the one that you see here as a 2-axle, 2-door bus. On the project, which is of course of more interest to you, I have to mention that there is some history. We started out, or Europe started out, to support such projects as of 2001, which in the meantime is 10 years ago. So we're not really starting from zero. The so-called CUTE buses, then the high fleet CUTE, the CHIC was the program that Marike talked about, and we have arrived now at the so-called high velocity project. This is the bus that we have supplied to Oslo in Norway. Again, the same bus, 3 axles, 3 doors or 2 doors, depending on the requirement. High velocity. You can recognize the V.LO. The V stands for Vlaanderen, which is Flanders. The L stands for Liguria, which is right here, and the O stands for, initially for Oslo, and later on Aberdeen took over in the program. You can also see our logo, which represents basically the earth, which we want to preserve so much, and the nature and the water, and the connecting dots being transportation. We are facing a major challenge in our mobility in the future. So let's connect the dots. The summary of the program is, and maybe for those who want to go into this, is about 31.5 million euros is the budget. We are 12 partners, 5 countries, 60 months of operation, 5 work packages in there, 28 deliverables, 219 months of work for all of us. Those are the partners in total. If you see, you have the operators because someone needs to do the service of the bus, which is the line in Flanders, RT in Imperia, and Aberdeen in Scotland. On the industrial side, we have Hool as the supplier of the buses, Denterm Power as the representative of the fuel cell manufacturer, Solvay as the builder of the fueling station, at least in Flanders, and Ballas Nedam will make projections as far as fuel cell stations, fueling stations is concerned. We heard Marike talk about higher. We have the University of Geneva as a partner to monitor the data. We will equip all of the buses with black boxes, and we will equip all of the buses with the possibility to remote diagnose. If there is a problem in the software, which is 90% of the cases, we will be able to remote diagnose what the problem is, send the software over the internet to the bus and load it up again. The region of Liguria, very familiar in this place, and Fit Consulting, who from Rome, who did the project writing. So a good batch of companies, operators, universities, knowledge centers to achieve a number of objectives. One, the very first objective is indeed to supply a total of 14 buses in the 3 regions that I mentioned. Then to establish 3 hydrogen production and refueling stations. To create a network of clean hydrogen bus centers of excellence. So we want the people to know. We want everyone to carry the project and the hydrogen as a fuel. We want to understand the total cost of ownership of the buses as it will compare to other systems in the future, be it zero emission or low emissions. We want to contribute to the standardization of hydrogen refueling infrastructure. We want to facilitate policies on environmental, health, energy efficiency, social and economic benefits. And above all, we want to increase the awareness and the promotion of hydrogen in this application. Hydrogen buses is a dreamed of application because the buses are under control of one entity. They only need to be fueled once every day, and the fueling takes place in the confines or in the site, at the site of the operator. So there is good reason to do it. In addition to putting an example for the public that public transport is by the public and for the public, and it has to be exemplary to do that. In a couple of years, we will be seeing electric buses running around all of our churches to find that the public transport cannot compete with the private car is not an option. This is not an option. We will again create private cars to congest the inner cities. So, if you go to the targets really of the program, then you can see that we want to have more warranty because a fuel cell is a very expensive piece of equipment. We want the bus to be available. It's not a showcase. We want to really deliver and use buses as they are normally used in everyday's life. And we want to reduce the consumption because obviously this is important for the environment and for the cost of the total cost. The fueling stations have their own targets, which is capacity, availability, the pressure that we need. We have 350 bars pressure in the tanks. There are 8 tanks on top of the bus and a total capacity of 1,600 kilo. But because hydrogen is so light, it's only liters, 1,600 liters, but because of hydrogen being so light, it's only 40 kilos. So, I'm done. Thank you.
Grazie ingegnere. Senta, qualche cenno sulla sicurezza.
Excuse me?
La security?
The safety.
Safe.
Yeah. Well, yes, because we all remember things that from the past which we believe could repeat. The safety of this bus is very high. As a matter of fact, it's more safe than a gasoline-driven bus. First off, the tanks can stand pressure. They can stand every impact. Hydrogen being so light, it will dissipate immediately into the air. We have installed in the bus, we have leak detectors in the fuel cell as well on the lines between the tanks and the fuel cell. We have an automatic fire suppression system that if ever something became so hot that it started to burn, then the fire suppression system would be activated immediately. Of course, because of the low flammability of hydrogen, the workshop needs to be equipped accordingly, so that you're not looking for conditions that could create a hazard.
Grazie ingegnere, grazie dei chiarimenti.